Welcome back. Our next keynote speaker continues several of the themes in her keynote that we have explored throughout the day: innovation, tradition, sustainability, but also the importance of diverse knowledge systems. Too often, the discussions about technology focus on the future, yet some of the most sophisticated and resilient solutions have existed for centuries. It is therefore my pleasure to introduce Julia Watson, who is the founder of the Low-Tech Institute and the Office for Intercultural Urbanism. Throughout her international recognized work, Julia demonstrates how indigenous and traditional ecological knowledge can inspire contemporary approaches for infrastructure, urban design, and climate resilience. Please join your hands for Julia Watson.
Thank you. Good afternoon. Today I'd like to talk to you about technology beyond modernism, looking at ancestral water wisdom for our post-carbon future. So, climate change began with a myth. Climate change is not a myth itself. It's incredibly and very real and immediate. But the mythology that was behind what caused climate change, this idea that humans are separate from nature, that was the flaw that began this collapse. So today I'm going to start talking to you about myth. And myth is a word that comes from the ancient Greek mythos, and it means the story of the people. And myths, just like lighthouses, they've guided mankind for millennia. And one of the oldest mythological threads of the world's indigenous people is that humans are part of nature, and so are our technologies. And this is the living root bridges of the Kasi people. You can see up here, this is a bridge with a young boy in front of it. These bridges are grown from 2 fig trees that are planted on either side of a river. These are the only bridges that can actually withstand the force of the monsoonal rains that flood through this landscape without being destroyed. And in fact, many indigenous communities actually don't have a word for nature, because there's no understanding or sense of separation of humans to nature. Instead, there's a reciprocity that happens. And this reciprocity is almost like a dance of kinship and care between your environment and between your community. And then, when did this new mythology begin? About 400 years ago, with the Enlightenment, this new mythology was constructed, that humans are separate from nature, and so are their technologies. And this modern mythology of technology, it was fueled by fire, it was fueled by the felling of our forests, the extraction of our resources from the earth, and it powered the age of industrialization. And then out of this mythology of industrial technology, this conception of the city arrived. The city as a machine. And then this new mythology, what it also did is it ignored millennia-old wisdom. It said it was primitive, it said it was unsophisticated and not important. And with that idea that all of this millennia-old knowledge was of no value, it changed our role from what had traditionally been that of the caretakers in that dance of kinship to the role of controllers. We're meant to control nature. And then it morphed into this idea that every landscape we touch, we reduce, we destroy, we kind of bring it down out of its natural state. For indigenous communities, that's not what happens. With an indigenous community interacting with their environment, they bring it up, they make it more healthy, more vibrant, more diversity. So that's a really different kind of understanding about the role of humanity and what a human can do in their environments. And so to understand how this idea of the city took shape spatially, we can then turn to modernism. And Louis Sullivan, he said, form follows function. And so in the late 19th century, this was mind-blowing. We said, let's strip all our buildings of ornament, let's create cities that are built with steel and glass and spurned by industrial innovation. And then cities were reimagined as these engines of innovation, and they were powered by coal and this pure industrial ambition. And we can say places around the world where this experiment has failed. And while it gave us forms that functioned like machines, it really rarely gave us forms that thrived. And cities with the European model, generally cutting off wetlands, burying rivers, it really replaced culture, it erased ecosystem. And what modernism gained in order, it generally lost in life. Now on this planet in upheaval, this edict really must change. So form following flux, meaning that forms that we design, they have to respond to this constant state of flux. They have to be adaptive, responsive, not just to environmental conditions, the flows of water, the responses of wind, but to cultural conditions, how humans actually interact with their landscapes. And so this is some of the predictions that we see. Right now, we're entering a period of time where we're seeing the largest transformation of landscapes and populations on the planet. And it's predicted that every year until 2040, 11 cities the size of London, London's population is 9.6 million at the moment, will be built. And so we can understand and make decisions about whether the city will remain extractive, or perhaps we can come up with models so that the systems, the infrastructures, the industrial processes that are part of our cities might be able to become regenerative. So what if the models actually already exist? And what if the technologies that are capable of shaping our post-carbon futures are actually pre-industrial, place-based systems that are culturally grounded and responsive to their environments, and they take up the ecological intelligence of their environments? So Indigenous technologies, they're not relics of the past, they are living systems. And they're capable of shaping the future of urbanism, of infrastructure, and of environments. So you can see, this is an image, this is a Chinampas. These are a system that is in Mexico City of agricultural islands. And this is where the pre-colonial city that sits under Mexico City, it was composed of. It was a city that lived in an environment of lakes. So all of this thinking, this is the foundation of low-tech. It's a framework that redefines technology through the intelligence of ancestral knowledge. So in 2019, I published a book, Low-Tech, Designed by Radical Indigenism, and in it, I just postulated whether ancestral knowledge is scientific climate technology. And it also questioned, why have these types of knowledge systems been excluded from our education systems, from our urban design, and from our industrial processes, when they are incredibly sustainable and highly sophisticated? So low-tech since 2019 has evolved into a global post-carbon movement. And it indicates, I think, that we're actually reaching a tipping point. And that tipping point is that we're moving from industrial systems towards systems that are ecologically responsive and a little bit more intelligent. So perhaps the emerging story of this century is that the city is starting to become a cultural ecosystem, more adaptive, more alive, and maybe a future where nature becomes the architect and culture becomes the engineer. And now with some of the most imminent threats facing communities, coming from water, a book that I published in December is called Low-Tech Water, A Field Guide to TEKnology. It was co-authored with 41 Indigenous communities and had over 150 contributors. And so what this sequel to the first book is actually documenting, yes, it's looking at these case studies of ancestral knowledge systems from around the globe that use the intelligence of water. But what it's also documenting is this global phenomenon that's occurring whereby Indigenous ancestral innovations and contemporary technologies, material systems, construction methods, data monitoring is actually being combined with this ancestral wisdom to form new types of post-extractive technologies we have never seen before. And so water presents also 10 principles for how would you even think of looking at this in the context of urbanism and urban design, in the making of cities. And so it proposes a framework for designing cities that are responsive to these ancestral systems. The principles begin with spiritual, a word that you don't often see used in design, cultural continuity, and mythology. So in the background of these 10 principles that I'm going to show you, these are projects that were done by my studio in the last 10 years. So this is actually a project that was done in Bali. That was the preservation of 16,500 hectares of rice terraces and water temples for UNESCO World Heritage Site. And we did that by understanding the geospatial, elevational, cosmological relationships that have been in place on that island for 2,000 years. It's called the Trihita Karana. And they preserve spaces and activate spaces completely based on cosmological understandings that actually are inherently sustainable and have conservation built into those systems. Number 2, collective governance, co-design, commons-based resource management. And this is exemplified with this Great Barrier Reef resource resilience network that was established between 14 different reefs and their communities around the world, involving traditional ecological knowledge and in understanding how we conserve our threatened reef systems. Number 4, ancestral technologies as innovation and infrastructure in our cities. This is a project which was the MAC Panama design competition that we just completed. That was a museum whereby we were looking at material geographies to shape our material systems in our landscapes and in our buildings to create the type of performance like water cleansing. Number 5, indigenous multi-species urbanism. Trying to understand how you can create spaces for our more than human friends that are in our landscapes. This is a project for the LA Olympics El Segundo City 2028 Olympic Gateway, whereby we were creating pollinator corridors for the El Segundo butterfly that is emblematic of the city. Water-centered urban planning, living systems as cultural infrastructures. In this project, we were working in Dubai. We were creating a whole new city center, and we were looking at indigenous infrastructures of water to create cooling and different types of canopy conditions to lower ambient air temperatures. Bio-based materials and bioclimatic architecture. Here, we're actually working on a pavilion for the Venice Biennale, using Korean medicinal herbs and embedding them into the materials that we're putting into the exhibition in the pavilion that can be activated by heat and touch and sound, so that you can get the healing properties without actually ingesting, but through experience in that particular environment. 9 and 10, industrial symbiosis and regenerative production and water, energy, and waste systems. So these principles first actually emerged during my work with Nike's innovation team, when we were trying to imagine how a value chain of a corporation could actually shift to biomaterials and then support these types of nature-based systems and solutions in the places and with the communities who were working in these environments that they were doing their production in. And then the question when I was working with Nike actually was, how do you actually look? What happens when you're in these landscapes and you're trying to adapt and you're working with these different communities and these organizations? So what we did with this project, we looked at, well, let's not just look at a product, let's look at a system. And how do we actually think about changing a system so that it actually be supportive of environmental conditions and communities? And what we started to do was say, well, the material geographies of everything that you put into your product, they don't just flow from different places, they also map. And once you start to look at where these material geographies lie, they are all across the world. So what if we started to look at how do we support these nature-based systems that are already producing materials like kelp that are being farmed by different communities who are part of the market economy, how might somebody start to support them by working with those communities? We began in Portland, and we created a hyperlocal lab whereby stewardship of some of the kelp forest regrowth conditions by the communities were then being supported by the production of biomaterials that could supply some of the chains in some pilot projects for the production of a completely biomaterial shoe. And then learning from that particular pilot and that hyperlocal living lab, how could we start to assist other communities that are producing these types of kelp biomaterials to then form sister chains, sister cities and hyperlocal living labs that can then support one another with knowledge systems, so that while production is still happening, some of these nature-based systems can be supported and scaled. So this is not industry as machine, this is industry as ecosystem. And so for the next section of the talk, what I'm going to talk about is that's the way that we can do projects, and that's how we can implement these ideas and principles. But for designers like myself, there's always these restrictions when we're actually building, these specifications. So I tried to think, how do we embed the idea of what water would do in this particular type of environment? What would water specify if it was in control of giving us specifications? What's the ecological intelligence embedded in water? And I came up with this list: living, coevolutionary, coenergetic, symbiotic, and cyclical. I'm going to take you through a series of these case studies from around the world that exemplify each of these specifications. So this is a community that lives in the West Coast, very near to the site where we're looking at production of kelp. They're the Swinomish. They're creating the first clam gardens that have been built recently in the last 400 years in the United States. And they're doing that. They're creating these 200-meter-long walls. They've been deploying these actually for 4,000 years, but they were banned with colonization. They're now redeploying them, not for food growing and harvesting, which is the reason they were first deployed, but they're doing that to mitigate climate events. So ancient technologies being redeployed to combat climate change for completely different or additive uses. And so this is the challenge that we have. This is how ancient technologies can actually become really relevant and begin to push the boundaries of how we're thinking about technologies that don't just fortify, but are productive in multiple different ways: food growing, biodiversity supporting the soils to stop erosion, stopping tidal events, mitigating storm events. The second technology is talking about coevolutionary. Coevolutionary simply means that these technologies have survived and thrived mostly over thousands of years because of the relationship between a community and a community's relationship with that technology. So this project is 2 hours from my home in New York City. It's a 6th-generation women's kelp farming initiative. They have been growing seaweed in this bay for 13,000 years. They've been doing that as a food supply. Today, that's changed. Today, they're doing it for ecosystem remediation because the bay is heavily polluted by sewage and by agricultural pollutants. So they're growing sugar kelp in this bay because sugar kelp is an incredible biouptaker of pollution. And it's cleaning the bay, so there's ecosystem remediation happening. There's a whole lot of other things that are happening as well. One of the major reasons the bay is so polluted is from industrial agriculture and the washing of synthetic fertilizers into the water system. Sugar kelp is biouptaking that. They're harvesting it, selling it back to the farmers. So there's only organic fertilizer now that's coming from your watershed being used to fertilize your lands, mitigating that large-scale pollution system. It's also carbon sequestering, it's creating biodiversity, it's creating new economic streams for this community. So this is a 13,000-year-old technology being deployed to deal with problems that are being experienced today. Coenergetic. So all of these systems are incredibly opportunistic. They're activated by very sustainable passive energy flows. And that just means that they're co-energetic with their environments. So this is a community, it's a university, and it's a rooftop, actually, of a building in Bangkok. So Bangkok was once a city that lived with water. There's not much water in this city anymore, it's concrete. But they're trying to understand how to live with water once again as the monsoon comes through every year. So this is a rice terrace building, 22,000 square meters of rice terraces covering a building at Thammasat University. It was designed by Land Process, and this is forming a circular system. Students plant rice, they learn rice cultivation, which is an ancestral form of production in Thailand. They're harvesting the rice is being cooked in the cafes, the students are then eating the rice, and then the waste is going back to fertilize the rice terraces in this system. There's rainwater collection that's supplying irrigation for this building, and this building is completely run with sustainable renewable energy. So it's forming this food, waste, water, energy, closed-loop circular system. Symbiotic. So they're also really intelligent because they create these conditions for interspecies exchange, and then they actually rely on those conditions to keep on functioning. This is pre-colonial Mexico City. What you see here that might look like highways, they're canals. What's in between are secondary canals. What might look like a city block, that's an island. These are where they grew the food. This is a community that was 200,000 people with a tribute of 5 million from around 1350 to 1520. It was called Tenochtitlan. And the Mexica people, they lived here. In 1570, around that time, conquistadors came in. What did they do? They cut off the water supply. 5 lakes were drained. We now have Mexico City that lies on top. Mexico City that is water scarce, that is hit by drought, that is hit by flood, that is having terrible issues with water security. But this whole system wasn't erased on the entire city. In the south, part of this system remains, and also in the east. This is called the Chanapas. These are raised agricultural islands surrounded by sacred willow trees that grow 8 harvests per year in a soil that's intensely lime, which is not conducive for growing food at all. But they've actually augmented the soil so much that it's incredibly fertile. So sometimes the answer isn't always looking at high tech, it's actually allowing a city to remember once again. This system grows food, it also cleans about 30% of the wastewater coming out of Mexico City. It sequesters carbon, it creates biodiversity, it lowers ambient air temperatures between 4 to 7 degrees. It's doing all of these free functions for the city. And it's also a beautiful, incredible, peaceful environment in a pretty chaotic place. So lastly, they're cyclical. They're triggered by the repetition of the sun rising and setting, days, season, years. So this is this project in the Yangtze Delta. It's the Sanjiotang system. It's polders, dikes, lakes, embankments. Sounds similar to maybe the landscapes that surround you. On the dikes, there's mulberry trees that are planted. So this is part of the Silk Road. It's part of the market economy. They're still growing silk and selling it to suppliers. But it's forming this closed-loop system that also protects the city that does the silk production from intense flooding in the Yangtze Delta. So the mulberry trees that are grown on the edges of the embankments around these polders, they supply food for silkworms. As silkworms poop in the water, they supply food for the fish and the aquaculture that's grown here. The fish poop into the water, and that goes down to the bottom. Once a year, they drain these areas, and the sludge is then used to fertilize all of the embankments, forming this closed-loop system that has run for 2,500 years. So one thing that's really important about what water documents is where these hybridizations are occurring. Between ancestral knowledge and contemporary design, everybody knows, I think everybody in this room might know this project, Sponge City. It's one of the project's most innovative versions of urban water management. It was developed by the late Kong Jianyu, and it is a contemporary expression of low-tech. So Yu was redesigning cities that were built to expel water, to be able to hold water, once again. This is Nanyang Fishtail Park. And he did that because as a child, he grew up in a landscape where he was watching the farmers augment the landscapes, building terraces and ponds and embankments. And he applied that to the way he was designing. This is Sanya Mangrove Park. It was once a complete concrete floodplain. It's been now adapted to be a mangrove forest condition that is with all these landforms that are storing, allowing water to move, moving water with the seasons. And so when I interviewed Kongzhan for the book, he really always spoke about his childhood and how important his childhood was in informing the way he designed. It wasn't that he was trained as an architect and that's what informed the way he was thinking. It was that he grew up in these landscapes. And in designing these systems, he was looking at the Sanjiutang, but he also said, I was looking at the Chinapas and the intelligence of that system. So these ideas are really informed by how we can pull this ancient knowledge in and co-design with communities and then create new ideas and technologies that are at this moment already making the most groundbreaking types of water evidence that we have on the planet. So the question I'm going to leave you with is this. What becomes possible when ancestral intelligence is introduced early enough to shape the imaginative nation of generations? Because as I said, Kongzhan Yu, who's designing the most groundbreaking model for water management in cities, which has been replicated in 100 cities around the world, he said it was because he was taught as a child and existed within those landscapes that he was able to evolve these most innovative types of management systems. Thank you.
Thank you so much, Julia. Of course, you're not leaving, but we have to rearrange the stage because we will have a panel discussion and you will be one of our guests. But thank you very much for reminding us that innovation is not always about inventing something new, but sometimes it's about recognizing and learning from wisdom that is already available for centuries. Thank you very much.